All right, here's a couple worded problems with trigonometry. The first one, Mount Rushmore National Monument. There's the top of it up here, and if I draw a line straight down and over, I'll have a 90-degree angle there. They say from here is 35 degrees to the top. You walk 250 feet closer, and then it's 50 degrees to the top. And they want to know how high Mount Rushmore is. So this one, it'd be nice to try and, you could use law of sines or law of cosines, probably law of sines, to figure out this side, but then you'd have to do some more work to get this side. So here's another strategy that you could use. And what I do is I set out both triangles separately. So here's the big one, 35 degrees, h is my height. And in this distance from here to here, from there to about here, it's 250. And I don't know how much it is from here to here. So let's just call it x. So that's this big triangle, that one there. Let's do the smaller one, that one. I'll draw it over here. Okay, so now the angle's 50 degrees. And I know this is the height. And this distance over here is x. Now both h's and x's are the same number. So what you can do is, it's very similar to the distance equals rate times time questions that we did. Solve for one of the variables, substitute, and then solve again. So here what I can do is, if the opposite and the adjacent side are in question, I can use the tangent ratio. Tangent's opposite over adjacent. So the tan of 35 is equal to the opposite side is h over the adjacent side, is 250 plus x. Similarly, on the smaller triangle, you get tan of 50 degrees is equal to h over x. Now, since both h's are the same, I can solve for h. So let me take this 250 plus x to the left side and multiply it by the tan of 35, and that'll give me h. Same thing over here, I'll get x times the tan of 50 is equal to h. Now these h's have to be the same height. They're both talking about the same height. So if this is equal to this and this is equal to this, then 250 plus x times the tan of 35 must equal x times the tan of 50. And from that point, you can solve. What I would probably do is figure out what this tan of 35 is and multiply it through, and then collect x's on one side and numbers on the other side. Now, I think that when you do this, it comes out to 356 or something like that. You'll have to do it on the calculator. But that is what x is. It's not what the height is. So if you want to know what the height is, you're going to have to plug that x value back into either that formula or back into that formula. I'd probably do this one because it's a little easier. So it'd be tan of 50 is equal to h over 356. And then solve for h. Hopefully that helps you. Okay, here's one. We've got a guy on a ladder, and I've got two triangles. One like that, and then I've got one like that. Okay, and one goes to the top of the building, the other one goes to the bottom. So what and I know this is 18.7 degrees. I know that distance between the buildings is 100, and I know this angle is 6.5 degrees. So I'm looking for the opposite side. We'll call that one x and maybe this one y. And I know that this is my angle, and in both cases the 100 is the adjacent side. So I'm looking for opposite over adjacent. That'd be tan again. So tan of an angle opposite over adjacent. So the tan of 18.7 equals the opposite side over the adjacent. Doing that same thing for the bottom triangle. you get tan of 6.5 is equal to y over 100. And then they want to know the whole building, the whole height. So when you solve for x here, that'll give you this distance. When you solve for y here, that'll give you this distance in there. So all you have to do is add at the end x plus y, and that'll give you the height of the building. Okay, here's another one. Architect designed a house 46 feet wide. Oh, this might not be the exact question you had, but it's similar. With a roof whose pitch is 11 by 12. So that means 11 rise and 12 run. Determine the length of the rafters needed for this house. Oh, okay. So here I've got my rafters, look like that. And they say the pitch is rise over run. So here would be a rise, that would be 11, and then the run is 12. This number down here is 12. Okay, so they want to know what the length of the rafters are. I believe they want to know what this distance plus this distance is. It'll be the same, so I'll just double it. But I got to sort of figure out what that is. They do tell me that the whole way across is 46 feet. Well, if I just went with the ratio that they gave you, 12 and 12, 12 plus 12, that would be 24. Yeah, but they say the house is 46 feet wide. So 24 doesn't work out. But what maybe I could do is do a ratio kind of thing. So half of that 46 is 23, right? So they're saying a rise of 11 gives a run of 12. So I'm saying that the run, instead of being 12, I want it to be 23. And x, so if I cross multiply and divide by 12. So whatever this number comes out to is, what was I solving for? Oh, this, whatever number this comes out to is, if it's 46, it'll be half that length of the rafter. And then all you have to do is double that, and that'll give you the length of the rafters. Hopefully that helps. If that doesn't, or if you don't quite get it, send me another note. Lastly, they've got a lightning detection. So they say a detector point Q is situated 15 miles west of point R. Got it. So west is going left, that's right. Then they say the bearing from Q to where the lightning hits due south of R, so that's right there, that's due south, is 37.6 degrees south, 37.6 degrees east. So they're saying go south and then bend over a bit, and that angle will be 37.6. But that's not really part of my big triangle here. So what I could do is figure out what this angle is. And to do that, it would be 90 minus 37.6. So that'll be 53.3, if I'm not mistaken. So that'll be this angle here. So if they want to know how far the lightning is from point R, this one, here's our lightning down there. Well, I already wrote it. If they want to know that, it's going to be opposite over adjacent, which is tangent. So the tan of an angle is equal to the opposite side, which I don't know, over the adjacent side. Okay, tan. Oh, I don't know this angle yet. Oh, but I do know if this is 90. Oh, no, I did figure it out. That's 90, subtract 37.6, get that. So the tan of 53.3 is equal to the opposite side. I don't know. It would be called Q. divided by the adjacent side, which is 15. Okay, so I go 15 times the tangent of 53.3. That should tell me what the distance from that one ranger station to the fire is. All right, hopefully that helps you with those 4 questions.